All right, everybody. Once again, good morning. We got a short week this week for you, just 3 days. Uh, your unit exam will be sometime next week. I got to run through my lessons and make sure, but I'm thinking maybe Friday of next week. What we're looking at today is describing the effects of a, b, h, and k on a function when we go from f of x to y equals a times f of b bracket x minus h n bracket plus k. This template is something that appears on a formula sheet, and I will provide you the formula sheet either today or in the next day or two, but it's the only real formula in this unit that we make use of on the formula sheet. And what I will tell you is you already know the answer to the question, what effect does a, b, h, and k have on an original function? It doesn't matter that this piles them all together. It combines all of these transformations. And that's why, by the way, this lesson is called Combining Transformations. Combining reflections and stretches and translations all together. It doesn't matter that they're combined. Whatever I've taught you and hopefully whatever you've learned about what a does to an original function, it will continue to play that role whether there's a b and an h and a k as well. Whatever I've taught you about what b does, it will do the same thing. H does the same thing. So if you can identify in this mess of stuff that h is equal to 5, then you know that somewhere along the road there's a translation of 5 units to the right. Again, everything you've learned about a, b, h, and k continue to be true. However, we have to apply the transformations in a particular order. And I don't want to get into it right now. I might discuss it with you later in the class. I might discuss it with you later in the unit. I might not discuss it with you. But this template that's on your formula sheet that we all follow is built by applying transformations in a particular order. Okay? The transformations need to be applied in a particular order, otherwise you don't get this template. And the order is really simple. You have to look at transforming the function by applying a and b first before you apply any changes for h and k. And I say it's really easy because there's a couple of things we can do to remember that. If you put those 4 parameters in alphabetical order, a comes before b, b comes before h, h comes before k. So if you do them in alphabetical order, you'll do them in the proper order. Alternatively, you could look at the order in which they appear in the equation or the template. A and B come first and then H and K. But I want to make a point to you here. A and B have to be applied first. That doesn't mean you have to do A before B. You could do B before A. All that is important is that A and B are parameters that you deal with completely before you start worrying about H and K. The order of A and B doesn't matter. The order of H and K doesn't matter. But A and B must happen before H and K. Does that make sense? You understand what I'm saying there? Okay. There is one little hiccup in this lesson, and I'm mentioning it now because it's going to be something that some of you on an exam will get caught on. And I'll tell you right now, it's something that might appear on a unit exam in 3 different places, in 3 different questions. And 2 of them could be a multiple choice numerical response and 1 could be a written response. So this one little thing, if you get caught on it and you don't notice it and you don't do it properly, can cost you 15% of the exam, maybe 20% of the exam. And all I will say to begin with is that when you make a decision about what happens to the function, make sure that you've written the function exactly as it appears here. Okay, so for example, if I give you a function that says y plus 4 equals something, then you have to rearrange it for y. You need to get the y by itself. Otherwise, you can't make a logical conclusion about what happens to the graph. This is not, this y plus 4 thing is not the tricky thing. There's something else about it that's going to be tricky. So we're just going to jump in. We're going to do a few examples, and then you're going to get lots of time today to practice this stuff. So I really don't want to go too fast here. I want to slow things down today to make sure that everything gets a chance to gel in your head. Given the graph of y equals f of x, there's the graph of y equals f of x. I've got it on 2 grids, but given that graph, sketch y plus 2 equals 2 times f of bracket 3 bracket x minus 4 n bracket, and write the mapping of the given point. So the first thing you have to do, since I made such a big deal about talking about this template, is you need to make sure that whatever you have on paper matches the template. And this is not a difficult thing. This is not quite in template form. You need to subtract 2 from both sides. You need to subtract 2 from both sides in order to see what k is. Now, that's not entirely true. I hope that everybody in the class can see, looking at that k is negative 2. Yes? But to be explicit, we would take that and we would write y equals 2 f of first set of brackets, 3 second set of brackets, x minus 4, close both sets of brackets and subtract 2. So all I've done is I've subtracted that 2 from both sides. And the first thing I would like everybody to do is to write in the value of a, b, h, and k in those 4 blanks. Which in and of itself is not a very challenging thing. I know that. A is equal to 2, b is equal to 3, h is equal to 4, k is equal to negative 2. And what we're doing, I want to make sure that everybody understands this, is we are taking the function y equals 2 f of 3 bracket x minus 4 n bracket minus 2, and we are stacking it in our brain for comparison purposes with the template. So when you compare them, a is equal to 2, b is equal to 3, h is equal to, that's an h is equal to 4, and k is, of course, negative 2. This is very important, so I want to make sure. Any questions with getting a, b, h, and k? Yep. Okay, so this is a common error. No, b is 3. So b is the number in the equation. Now, if we start to talk about the stretch factor, then we would say the stretch factor is 1/3. But whatever number is there is b. And this is, you're going to get an assignment here maybe tomorrow, a written response assignment. And what people will often do is on a written response, they will say, well, b is 1/3. And then they will proceed to stretch things properly by a factor of 1/3. But even though the stretch factor is 1/3, b is 3. b is the number in the function. Have I answered your question? Okay, good. Any other questions about getting a, b, h, and k? Yep. Why do I not what? Multiply it through, you mean? That's a really good question, and the answer to that is going to be important for later. It has something to do with the trick, the tricky thing. It's because in the template, the b is not multiplied through. Now, if the b were multiplied through, then we have to undo that because we don't want it multiplied through. We want there to be a set of brackets here around the x minus h, and we want the b to be multiplied by that set of brackets. Have I answered your question? Okay. Those are two very important questions, very good questions. And that's why, we got to get those misconceptions or those little things out of the way. In the case of what you're asking, Chismita, that might be a case of thinking too much. If it matches the template, leave it alone. And that's maybe the bigger picture is it's got to match the template. Any other questions about getting A, B, H, and K? Okay, so given that we know A, B, H, and K, you should all understand the effects that these have. This will be stretched vertically by a factor of 2. This results in a horizontal stretch by a factor of 1/3. This results in a shift of 4 units to the right, and this results in a shift of 2 units down. It's taken me many years to realize that, everybody, well, I know everybody thinks differently, but the level to which people think differently is really vast, the separation between people. So one of the ways we can do this is to do this in 2 steps. To not worry about H and K right now, but to worry about the effects of A and B and deal with them together. Now, if I wanted to really, really simplify things, we could do one graph showing what happens after we apply A, and then take that and apply B to it, and then take that and apply H to it, and take that and apply K to it. So we could have 4 graphs to complete here. I think 2 is probably, I would expect you to be able to follow a 2-graph kind of approach here. So if I take a key point here, and I'm going to have to get some rulers to you. If I take a key point and I start looking at the effects of A and of B, I need to take that key point and stretch it vertically by a factor of 2, so it's going to go twice as far away from the x-axis as it currently is. And I also need to, I could say at the same time, or I could say followed by, it doesn't really matter. I need to stretch that key point that I've highlighted in red horizontally by a factor of 1/3. In other words, that point is going to be twice as far away from the x-axis vertically and 1/3 as far away from the y-axis horizontally. And I'm doing this without mapping. I don't really need to use an official formal mapping here. I can just say that if I double this vertical distance, it's up here at 8, because it was vertically 4 away from the x-axis. And if I multiply the horizontal distance by 1/3, well, right now it is 6 away from the y-axis, so 1/3 will take it 2 away. So after applying the effects of A and B to that first key point, that's where the point lands. If I go to the second key point, so now we're focusing our attention on the bottom part of that first V in the W, and I stretch that vertically by a factor of 2, it will not move because it is on the x-axis. And now I stretch this horizontally by 1/3, so I have to figure out what 1/3 of 2 is. So 2 times 1/3 is 2/3. It's going to be approximately there. And this demonstrates to you that life is not always going to be perfect in this course. It's not landing on, a precise crossing of the grid lines. But I can connect these now. And then I can go to my third key point. So on the blue graph, I'm moving left to right. I've taken the first 2 points and transformed them. And now what I'm going to do is take this third point. I stretch it vertically by a factor of 2. It's going to be twice as far away from the x-axis. I stretch it horizontally by a factor of 1/3, which means points to the right of the y-axis get closer to the y-axis, points to the left get closer. A point on the y-axis doesn't move. And then I can connect this. Moving on to the next point, a vertical stretch by a factor of 2 of any point on the x-axis is not going to change its position. It's not going to get further or closer away from the x-axis. But the horizontal stretch by a factor of 1/3, we'll take that horizontal distance of 2 and multiply it by 1/3, giving us 2/3. And finally, this point, I stretch it vertically by a factor of 2, which is going to put it twice as far away from the x-axis, up at 8. Horizontally by a factor of 1/3, which is going to put it 1/3 as close to the y-axis. It was 6 away. 1/3 of 6 is 2. And we can complete the function. So now what we're going to do is we are going to take this whole thing, and that's just A and B. We now have to shift it 4 units to the right and 2 units down. So the left-hand part of the W right now is currently residing in this location. I need to move it 4 to the right and 2 down. I might have misspoke a minute ago. I might have said 4 to the left. If I did, I apologize. But this is definitely shifting 4 to the right and 2 down, which means 1, 2, 3, 4, and 2 down. It will land here. Now, you don't have to do that with every point. What you could do is say that I know if I shift the whole thing as a unit, right and then down, these 2 points will always be 4 away from each other. So, I mean, I could take this point, which currently resides here, and go 1, 2, 3, 4, and down 2. Or I could have just plopped it down there because I know the 2 peaks of the W are 4 apart. Similarly, what I could do is make an observation that this central point of the W is halfway between the peaks, and it happens to be 4 below them. So I could simply go halfway between this and go 1, 2, 3, 4. Or I could take this point, which is right here, and shift it 1, 2, 3, 4, and 2 down. In either case, it ends up there. If you want to use kind of an approach of the relative position of these points, the 2 bottom pieces of the W are points, and the W are 4 below, and they are 2/3 away from the central point horizontally. So I could just say 1, 2, 3, 4, and 2/3 away on either side. And then we can connect them. And you could have been connecting them all along, actually. Or again, you could have taken this point here, that's right here, and shifted it 4 to the right and 2 down, and you would have seen that you land there. I'll be honest with you, and I always thought this was the case for everybody, but I'm mistaken. To me, breaking it into 2 graphs is more confusing and more work than doing it all in one shot. But I've realized over the years that not everybody can process doing it all in one shot. I just want to make sure that we're done. Yeah, we'll do the mapping in a bit. I'm not concerned about the mapping. Could we have done this in one shot? Well, it requires more organized thought. But let me demonstrate to you that it can be done. I'm not going to rewrite these. I'm just going to write that this is a vertical stretch by a factor of 2. This is a horizontal stretch by a factor of 1/3. This is 4 units to the right, and this is 2 units down. What I'm about to do, I don't I don't think it's that challenging well, it's not challenging for me. As I said, I think, and maybe it's just me, I think doing it in steps, I'm more open to making a mistake. Whereas if I do it in one shot, I need a point here. I take a point, and I have to be organized. I'm going to stretch it vertically by a factor of 2, which puts it twice as far away. I'm going to stretch it horizontally by a factor of 1/3, which is going to put it 2 away. And then I go 1, 2, 3, 4 to the right and 2 down, and then I go to my next point. To me, that way I'm not going from point to point to point to point to point and then repeating the process starting with the points again. If I were to go to the next one, I double that distance vertically, nothing changes. I multiply it by 1/3, it goes there. I go 1, 2, 3, 4 to the right and 2 down. To how many of you does this make sense? Well, you would probably do it this way rather than breaking it into pieces. So we're apparently in the minority. But if you're like me, you would wonder why you would even want to do it any other way, because it's just so quick. Anyway, this leads us to our mapping, everybody. And I want to do the x comma y mapping first. What is it we do first? Well, we take the y coordinate and double it, don't we? That's what we do. We double the y coordinate. And then, before we move on to h and k, we multiply the x coordinate by 1/3. That's what we're doing when we're taking 1/3 of the horizontal distance to the y-axis. Then we shifted it 4 units to the right, which means whatever we got after we multiplied x by 1/3, we're now adding 4 to it. And then we shifted it 2 units down, which means the new y-coordinate, after we double the original y-coordinate, the very newest y-coordinate is then going to become 2 less. And that's the mapping. And I know if I asked you to map all of these points, that it's probably going to be more divided down the middle in terms of numbers. Many of you will want to do one thing, and many of you will want to do the other. For example, -6 comma 4. Well, we've already seen that -6 comma 4, which was this point, eventually lands here at 2 comma 6. So one of the ways to map -6 comma 4 is to actually complete the graph. Did I just say 2 comma 4? 2 comma 6? 2 comma 6. And say that this maps to 2 comma 6. However, that's again what I refer to as a concrete approach. You need to see it on paper. That's kind of a concrete physical thing. Is there a more abstract approach? Well, definitely you could use this mapping statement that we have here. That really I just need to take 1/3 of the original x coordinate and add 4 and take 2 times the original y coordinate and subtract 2. And if you figure out what 1/3 times -6 is, you'll get -2. -2 plus 4 is 2. And if you figure out what 2 times 4 minus 2 is equal to, well, 2 times 4 is 8 minus 2 is 6. First of all, let me point out to you, the only reason you can use a concrete approach is because you have a graph. I don't have to give you a graph. Although I suppose you could still plot the point. Do you remember that there was a question somebody had asked about where we had an original point? This was from yesterday's or last day's practice. And we went over it in the seminar this morning, where the original point was 2 comma 8. And we did stuff to it. And I told you, I don't want to have to plot the point on a grid paper to find out the answer to the question. That's kind of what we're dealing with here. So, very similar to what we've done in the past with mapping. I don't particularly care about the individual numbers here, but let's maybe do one more or two more. Let's do maybe a tougher one, which would be, say, this point. And this point has an x coordinate of 1, 2, 3 1/3, which is 11 thirds. Monday morning and all, can you confirm that 3 plus 1/3 is 11 over 3? No, it's 10 over 3. It's 10 over 3, isn't it? Even as I asked that, I realized it's 10 thirds. Comma, -2. So that point went from here to here. That's the one that we started off with at -2 comma 0. So if I load -2 comma 0 into my mapping, my mapping is 1/3 times -2 times x plus 4, comma 2 times y, which is 0 minus 2. What do I get if I take 1/3 times -2 and add 4? And quite frankly, I don't care if you use your calculator. Use your calculator. Figure out what 1/3 times -2 plus 4 is in fractional form. We better get 10 over 3. And you get 10 over 3. Figure out what 2 times 0 minus 2 is. I hope you don't need your calculator for that. 2 times 0 is 0, minus 2 is -2. So this maps to 10 thirds, comma, -2, which is correct when you look at the graph. So I don't think we need to do the mapping of all of these points. Next time I prepare this unit for this course, I'd probably just pare it down to a couple of points. Any questions with that first example? Go ahead, Ian.
When we're writing down coordinates, does it matter if we write it in mixed fractions or entire fractions?
I don't quite know why the answer to this is what it is, but I would avoid mixed fractions. You're not likely to see this at this level. And the reason is, particularly when things become algebraic, you could easily interpret this as meaning 3 times 1/3. Maybe it would be wrong, because that's not what it means. We like improper fractions, or whole fractions, like 10 over 3 and not 3 1/3. But does it really matter? No. If you did something on a written response, it wouldn't be marked wrong if you use the mixed fraction. Any other questions with this example? I mean, mixed fractions certainly show, to me, more of an understanding of what the number is. 3 1/3, I get. 10 thirds, I got to kind of process it. But all right, so example 2 gives you an original function, and I've got it on the right here, and a new function. And you're asked to determine the equation of the new function, m of x. So what you need to do is look at going from the original into the transformed, and identify the values of a, b, h, and k required to get to the new graph. And remember that A and B happen first. So the tips and strategies I'm going to give you here are just that. They're tips and strategies. The first thing I want you to do is look at the general shape of the original graph and the general shape of the transform graph. Has anything been flipped upside down or left to right? No. The bottom part of that V, well, the corner of the V is on the bottom on the blue graph, and the corner of the V is on the bottom on the red graph. So it hasn't been flipped vertically. The flat plateau of both graphs is on the left-hand side of the graph, whereas the V is on the right-hand side of the graph, so nothing has been reflected horizontally. And what that tells us, this is important, it tells us that A and B are both positive numbers, because there's been no vertical and horizontal reflections. Then let's deal with A. A, other than the fact that it's positive, would be a number that you multiply the vertical height of the original graph by to get the new height of the original graph. Yep.
Something else that I just noticed right off the bat.
Can you repeat? Can you start again, please?
Something else I noticed right off the bat
Yep.
is with H, you could tell H would be -1 because on the original graph, the 0 minus 2 point is moved to the left once.
Okay. And let me ask you a question here. So we've gotten a little bit away from A and B, but why does that work for that point? What Jonathan is saying, Jonathan, right?
Yep.
What Jonathan is saying is that when you compare the location of this point on the original graph to its kind of sister point on the new graph, it's 1 to the left. But, so H is -1. And I will give you that. I will say H is in fact -1. But why does that only work for that point? Why doesn't it work for that point I've circled on the right, which is 6 away, and now it's 4 away? According to that logic, H should be +2. So why, and I'm kind of jumping ahead here, but why does that logic of looking at the points in green, why do you think it leads you to the correct conclusion that H is -1? That is correct, but I will explain it in a different way in a bit. But if you use any other point, it won't work. And I don't want you to answer that. If you can answer it in your head, that's great. The point I want to make is be very careful about picking a point and making that decision. Okay? Because it may not work. Okay? For example, you might say that this point is 3 away from the x-axis, and yet here it's on the x-axis, so k must be -3. And I don't believe k is going to be -3 necessarily. So do you know, I'm not asking you to tell us why, but do you know why it works for that point at 0, -2?
Yeah.
Okay. Did you know why it worked for that point when you chose that point?
Yeah.
Okay. And I know that to the rest of us, we're kind of speaking in code, Jonathan and I, but we'll bring this all together and include everybody in a minute. So going back to my question, compare the height of the original blue graph to the height of the new transformed graph. I'm talking height, the total distance from the bottom to the top. If it's twice as tall, then H, sorry, I got sidetracked with the H thing. If it's twice as tall, then A would be 2. I hope you notice that both graphs are the same height. Yes? If I count from the lowest point up to the highest point, it's 1, 2, 3, 4, it's 6. And over here from the lowest point to the highest point, it's 1, 2, 3, 4, 5, 6. And that tells us that A is +1. Nobody has asked this question yet, so I'm going to ask it now. If there's no vertical stretch, then A is 1. Okay? What if there was, so I'm not talking about this right now. What if there was no vertical translation? What would K be?
Are you asking?
I'm asking you to think about it. Arden, what do you think the value of K would be if it doesn't shift horizontally? Or vertically? Vertically, rather.
Doesn't shift vertically.
Yeah. So I'm asking everybody about what is K if there is no vertical shift. Translation. And this is important enough for me to just really slow down and shift gears. A is 1 if there's no vertical stretch. A is the parameter that deals with vertical stretches, and if there's no vertical stretch, A is 1 because it maintains the same height. I'm saying, what is K if there's no vertical translation? Do you know now? But there's an actual number we can put in. For any graph. So everybody, what I'm saying is, if it doesn't shift vertically, what is K? It's 0. So there's a difference here that if there's no shift, the parameter is 0. Because if it were positive, it would shift up. If it were negative, it would shift down. That's kind of a different approach to A. If there's no vertical stretch, you don't say A is 0, because if A were 0, the whole graph would disappear vertically. Okay. So A is 1. I want you to take a look now at we're not looking at the y-axis here. I'm just asking you to look at the width of the original graph and look at the width of the new graph. I'm asking you to measure how wide each of the two graphs are. And to go from F to G, we go from a width of, what do we have here? 4, 6, 8. The width is 8, and then over here, the width is 4. So we're going from the blue to the red on mine. I didn't print yours in color. And that means that the blue graph horizontally is being stretched by a factor of 1/2. So we have a horizontal stretch. To go from here to here, we have a horizontal stretch by a factor of 1/2. So Marcel, if the horizontal stretch is 1/2, what number do we put in the equation for B? 2. So we've got A and B. And A and B are found basically by looking at whether the orientation has flipped or not, left or right, or top or bottom. Doesn't matter which one you look at. Well, up, down will lead you to A being negative if it's reflected. Left, right will lead you to B being negative if it's reflected. But to determine the actual values of A and B, you're simply looking at the size vertically of the graph and the size horizontally of the graph. So now how do you find H and K? And there really is, you could make this complicated and set up a system of equations, but that's a nightmare. What you do is you pick a point and you apply A and B to that point and find out how far short you come from where the point should be. So I'm not sure you're going to do a lot of writing here right now, but if I take this point and I stretch it vertically by a factor of 1, it doesn't move. If I stretch it horizontally by a factor of 1/2, it will end up being here. So this is where this point on the original function will land on the transformed function if I just apply A and B. Now, where is that point supposed to be? It's supposed to be here, isn't it? So this point, after the transformations of A and B, lands at -3, 4. But man, we need it to be at -4, 1. So how do we shift that point at -3, 4 to get it to be at -4, 1? Well, -4, 1 is here. So it's looking as though I have to shift it 1 to the left, which means H is -1, and I need to shift it 3 down. So H is -1 and K is -3. Now, what if you didn't pick that point? What if you picked this point, which has to eventually land here? Well, if I stretch it vertically by a factor of 1, it doesn't move. Horizontally by a factor of a half, it lands here. So this is the original, this is the transformed, and the transformed lands at negative 1 comma 4. But I want it to be at negative 2 comma 1. This gets messy. How do I go from negative 1 comma 4 to negative 2 comma 1, which is here? I have to go 1 to the left and 3 down. And what I'm telling you is if you've done your job properly, it won't matter which point you choose. Transform the point you choose with A and B and find out what additional translations need to happen to get it to be where you want it to be. So that being said, here's the equation of our function. I'm simply going to load everything that I've determined about those 4 parameters into this template. That's all I'm going to do. I'm going to write those 4 numbers in there. And it'll be y equals, I don't really need to write 1. We could. You don't need to write the number 1 there. F of bracket 2 bracket x minus negative 1, close all the brackets, minus 3. So that's the equation of the function. Jonathan, going back to your observation that if we would have looked at 0, negative 2, and noticed that we have to shift it 1 to the left, we know h is negative 1. Why does that work for that point?
Because it is on the y-axis perfectly. It doesn't matter. It won't matter if it wouldn't matter what b is because we're constantly remain at that point.
Excellent.
The only way when you left or right is if h was positive or negative.
All right, so what Jonathan's doing is he's saying I notice that this original point is on the y-axis, which means b will not affect it. And he's recognizing that the x-coordinate there is 0 and b has to do with changing the x-coordinate. And since it ends up being 1 to the left, h must be negative 1. I suppose we could try to do the same thing with k, except we don't really have a precise point on the x-axis. So your strategy for finding h is perfect, but then it still leaves us with an unknown about k. However, once we do shift this 1 to the left, you can see that it needs to be shifted 3 down. What the challenge is if this is a written response, you have to be able to explain that. So if I give you an assignment or a written response exam question, I say, draw the new graph and explain how you got the coordinates, or explain how you got the parameters in this question. As long as you're able to put that into words, that's great. If I do give you this question and you do it the way I do it, then you need to actually write out using words. When I pick the point, negative 6 comma 4, and I stretched it vertically by a factor of 1 and horizontally by a factor of a half, it landed at, I forget where. And then in order to get it to be at the place where it should be, which is negative 4 comma 1, I would need to translate it 1 to the left and 3 down. All right, let's try another one. This time I would like everybody to take a minute, and I would like you to write, we're going again from the blue to the red, and I've just reproduced the blue graph again up here. I would like you to write the values of A and B, and then we will get to H and K in a minute, but I want you to take a look at A and B first. I noticed two things about the graph vertically. The height of the graph has not changed, and the orientation vertically has not changed. The point is still towards the floor. When I look at the horizontal aspect of the graph, I notice that each of the two graphs are 8 wide. So the width of the graph hasn't changed, but it's been reflected horizontally, which means b is -1. And that means I can pick a point and apply those two parameters to it. And all of our discussion, especially with Jonathan picking that particular point aside, of all of the points on this original function to pick, this is your wisest choice because it's not affected in this question by A and B, is it? So if I pick that point and I translate it by stretching it horizontally by a factor of 1, vertically by a factor of 1, and reflecting it horizontally, where does it land? Right where it is. It's not moving. It's invariant because of A and B. And then when I take a look at where it should land, so it's landing here, and it should land here. Oh, well, surprise, surprise. It's the same set of translations that we had in A. And had I realized that when I made this question, I would have chosen different numbers. So that means h is -1, k is -3. The function is y equals f of -1, x minus -1, n bracket -3. So take a minute. Does anybody have any questions with B? Go ahead, Ian.
Never mind. Nope, I don't.
Are you sure?
Yeah, I thought that was the final point was on the 4, and that would make it -2.
Okay. Any other questions? All right. So final example, the graph of root x is transformed to this new function. Identify the values of a, b, h, and k. Now, it doesn't matter that it's root x. We'll get to the root x part in a second, but I would like everybody to focus on the function notation, and I want everybody to identify the value of a, the value of b, the value of h, the value of k, and write those numbers in the 4 blanks. And for the time being anyway, don't worry about graphing y equals root x. The shape of y equals root x is totally not relevant, okay? I could have put y equals sine x. I could have put y equals cos x. I could put y equals log base 5 of x, even though you don't know what that means. I think it's pretty clear that a is equal to -4. I don't think there's any discussion that needs to be had there. And that b is equal to 3. I also believe that everybody should get k is equal to 8. However, and I won't put you on the spot here, but I know from experience that right now at least a third of you probably wrote down the wrong value for h. After instilling that wondrous sense of confidence in you, is there anybody willing to volunteer what you believe h is equal to? Jonathan. It is not 12. Be honest. It's just us. Put up your hand if you thought it was 12. So it's about a third. I know from experience. Shazmaida? 4. Why is it 4? Where'd the 4 come from? You're right. Right. So, and the way you're doing it, you're kind of thinking backwards, and I'm going to think in the opposite direction to what you're thinking. The template is y equals af of b bracket x minus h n bracket m bracket plus k. And what Shazmaida is saying is, since we have 3x minus 12 and we know that b is 3, h must be 4 because 3 times the -4 would give us the 12. And what I'm going to do is, and that's perfect, but what I'm going to do is just suggest to us that what we need to do is say this thing highlighted in blue is not fitting the template. I need to do something with that 3. So I'm not saying, what would I multiply the 3 by? I'm just going to factor the 3 out, which is going to amount to the same thing. Because to factor the 3 out, you're going to say, well, what do I multiply 3 by to get 12? When I put this into the template form, I'm going to have, by the way, sometimes I'll put a square bracket there, sometimes I put round. It doesn't matter. I have to factor 3 out of 3x minus 12. When I take 3 out of 3x, I'm left with x. When I factor 3 out of negative 12, I'm left with negative 4. So h is 4. Comparing x minus 4 to x minus h gives h is 4. And this is the thing that could cost you 15 or maybe even more % on an exam, is not noticing that. And I could and will repeat this idea 5 more times throughout the unit, and some of you will still, unfortunately, make that mistake. So those are the values, which the question doesn't ask us, everybody, but if you wanted to, and we have time, it's not that big of a deal. This is a vertical reflection. Again, don't abbreviate on an exam with a written. It's a vertical stretch by a factor of 4. This is a horizontal stretch by a factor of a third, which you would write in words. This is a shift of 4 units to the right and 8 units up. Those are the effects that it would have on the graph. The final part of this example is to just write out the equation of the function. So let me rewrite this. G of x is equal to a, which is negative 4, f of, in brackets, b, which is 3, x minus 4 in its own set of brackets, plus 8. So if f of x was root x, I'm just taking this opportunity to review with you function notation and what it means. If I said f of x is root x, and then I said, what is f of hearts? Well, it would be root hearts. F of x is root x, f of 3 is root 3, f of hearts is root hearts. So this is root 3 times x minus 4. It's the b times the x minus h which goes in for x, because it's f of b times x minus h. So this is going to illustrate something I think that I haven't talked about before that is, I believe, important. This parameter of b and this parameter of h are being operated on or included in x before the function happens. And that's what makes them horizontal in nature of change. However, the negative 4 happens afterwards and the 8 happens afterwards. So after you operate on x, which is a horizontal change, then you're going to multiply by negative 4, which will change things vertically. Then you're going to add 8, which will change things vertically. So the a and the k are outside of the function, which means the a and the k are operators on y. Just something to think about. It's not a crucial idea. So that's the equation of the function. Finally, I said to you maybe 5 minutes ago, forget about root x. It doesn't have to be root x. It could have been, I said, and you don't need to write this down, it could have been that f of x was log base 5 of x, which is written this way. Could have been that. So what would g of x be? Well, g of x would be log base 5 of b times x minus h, because it's f of that, so I put that in for x, and then we would have a negative 4 in front and a plus 8 here. Again, the b times x minus h goes into the function. Any questions with that final example? Go ahead, Ian.
Will the function do like another set of,
Can you start again, please?
will the function, depending on the function, can it do another set of like translations?
Yep. And you're going to see that for sure. So what, and I don't think you're going to see it today, but you'll see it in chapter 2, where you're told that f of x undergoes translations described by these 4 parameters to produce g of x, and g of x is then reflected vertically across the x-axis. What's the equation of the new function? And the answer would be that, because reflecting across the x-axis is multiplying the function by -1. So you'd multiply the entire function by -1.
Also, on the earlier question, you said that we can do it the way that you did, and there is a more ugly way of doing it with the system of equations. Are we going to be expected to know how to do it with the system of equations? The plot points.
I would say that if it's written response, you can do things in any of the ways we've talked about, unless it says algebraically. So as soon as you see the word algebraically, and it doesn't matter what the specifics of your question are, if you see the word algebraically, you cannot say, well, when I put the point on a graph, that's not an algebraic method. Algebra is using symbolic mathematical language on paper. However, the other side of that is if it's not written response, but multiple choice or numerical response, I can build multiple choice or numerical response using multiple mathematical approaches. So although with a written response, you have an option to pick the method you're going to use. If it's a multiple choice, you don't have an option, so you need to be conversant in all of these different methods. So I can give you we did some problems where we solved them using mapping. If mapping's not your jam, too bad, because there's going to be multiple choice numerical response questions that have mapping in them, so you need to understand it anyway. I hope I've answered your question. Okay. So you can see what the assignment is. You got about 20 minutes here